Good day, everyone. I'm Apphia Ackon, and I'm presenting on the leakages between Gulf of Guinea SST and seasonal extreme rainfall events, evaluation of semipsis GCMs. So, rainfall is an indispensable weather element that controls nearly every socio-economic activity. As a result of climate change, extreme rainfall events has become more frequent. The effects of these rainfall extremes include loss of lives and valuable properties. A major driving factor of rainfall is known to be sea surface temperature anomalies. This has led to many studies to investigate this relationship, with most of them focusing on how global SSTA affects rainfall mean and extremes on annual timescales. And we know West Africa depends on rain-fed agriculture, and variations in seasonal rainfall affect crop yield. In that, prolonged dry and wet periods affect agricultural productivity. Therefore, it is important to study the influence of local SST, specifically the Gulf of Guinea, which is the southern boundary of this subcontinent, on seasonal rainfall extreme. Also, there is a need to evaluate how climate models represent this relationship, since they are relied on for future climate projections. The aim of this work is to study the linkages between Gulf of Guinea SST and extreme rainfall events. The specific objectives are to assess the spatial correlation between Gulf of Guinea SST and rainfall of both observed and model datasets, and lastly, to evaluate SST biases of models on seasonal timescales. The research questions for this work include: is there any linear relationship between rainfall and Gulf of Guinea SST on seasonal timescale? Which of these rainfall indices are strongly affected by Gulf of Guinea SST? And how do some semipsis models represent this relationship? From this table, the two rainfall extreme indices used are R10mm, that's heavy precipitation days, and R20mm, very heavy precipitation days, and standardized anomaly index was used for the SST. GPCC and HADIS data were the observed datasets used. 6 semipsis models were employed, and the period of study was from 1982 to 2012. The spatial correlation of rainfall in Gulf of Guinea SST of the observed datasets are as follows. These are the results for the correlation between mean rainfall in Gulf of Guinea SSTA. The maps on the left represent the correlations, and the maps on the right represent the significance level. Here, 95% is considered to be significant. So, for DGF and MAM seasons, we can see that we have weak correlations for these seasons. But for JJA and SON, strong positive correlations, which are significant, are observed over the coastal countries. And for SON, significant strong positive correlations are also recorded over the southern parts of the coastal countries, meaning that increase in SSTA brings about increase in rainfall over these coastal countries. This slide shows the correlation between R10mm and Gulf of Guinea SSTA. So DGF and MAM seasons recorded weak correlations, but it wasn't over the entire study domain, but just some parts of the study domain. And for JJA and SON season, significant strong positive correlations are observed over the coastal countries for JJA season, and for SON season, significant strong positive correlations continue to dominate over the southern parts of the coastal countries. This implies that Increase in Gulf of Guinea SSTA brings about increase in R10mm. For the correlation between R20mm and Gulf of Guinea SSTA, here we can see similar results as was observed in R10mm. DJF and MAM continue to record weak correlations, which was not over the entire study domain. However, JJA continued to record significant strong positive correlations over the coastal countries, while SON seasons also recorded significant strong positive correlations over the southern parts of Ghana, Togo, and Benin. The spatial correlation of rainfall, mean and extremes and Gulf of Guinea SSTA of some synopsis models are as follows. The correlation between mean rainfall and Gulf of Guinea SST of some models as observed here. Here, two seasons are only considered, that's JJA and SON seasons, since they showed interesting results from the observed. So for their models, MRI, HAGEM, and GIS could not reproduce the positive correlations that were found in the observed datasets. For the observed, we could see strong positive correlations over the coastal countries for JJA and SON seasons. However, for MRI, HAGEM, GIS models couldn't reproduce this relationship. CNRM model also couldn't reproduce the significant strong positive correlation over the coastal countries. UKESM performed quite better by reproducing the positive correlations over the coastal country, and GLDL-CM4 also did well by representing the positive correlations that were seen in the observed datasets for countries like Ghana, Togo, and Benin. And for SON season 2, it could reproduce the correlation for some parts of the coastal countries. For the correlation between Gulf of Guinea SST and heavy precipitation days for the models, here MRI, HAGEM, and GIS continue to perform poorly by not reproducing the positive correlations that were observed over the coastal countries for both JJA seasons and SON season. Here we could see HAGEM also couldn't reproduce the relationship as well as MRI model. CNRM CMCs continue to perform not so well in representing the relationship between heavy precipitation days and Gulf of Guinea SSTA. UKESM also couldn't represent the positive correlations that were observed. However, GFDL-CM4 performed quite well by representing the significant positive correlations over the coastal country. This slide also shows the correlation between R20mm and Gulf of Guinea SSTA. For MRI model, you see this model couldn't represent the positive correlations over the coastal countries for JJA. However, for SON, weaker correlations are observed. And for HAGEM and GIS, they couldn't represent the correlations that were seen in the observed. They rather represented negative correlations, whereas it's the reverse for the observed. Model CNRM and UKESM couldn't capture the positive correlations which are significant over the coastal countries. But GFDL-CM4 did well by capturing the significant positive correlation over country like Ghana. However, for SON seasons, it couldn't capture the significant positive correlations over the coastal countries. Lastly, in assessing the Gulf of Guinea SST biases, it is realized that one biases continue to dominate over all the models that were used in the study for the 4 seasons. So, in summary, over the coastal countries, Gulf of Guinea SST has influence on rainfall mean and extremes for JJA and SOM seasons. Also, most synopsis models could not represent the relationship between Gulf of Guinea SST and rainfall for the summer and autumn seasons. GFDLCM4 could represent the leakages between rainfall mean and extreme and Gulf of Guinea SSTA for the monsoon season over some coastal countries. And one biases are found in all the synopsis models used in this study. Thank you.